Okay guys, so I thought it might be helpful to maybe do these examples again, just not in class, so that you can pause it and you can work with me on this. So we're going to do one of these with a log-log scale and one as normal. So we'll do the normal one first. Again, we want to use a scatter plot, not a line plot, and since we don't have an equation here, these are what we would assume would be experimental data, and so we're just going to use points. The next thing I would probably do is I can add elements to what's going on. So if I started at the home and I click on this chart, now I come over here to design, and here I can change to the quick layout that better suits my needs or what I think works best for me, which in this instance looks something like this bottom left one is the one I like to start with, and then I add on a chart title to it. So I could also add on grid lines, I could take away grid lines, maybe I just want the major grid lines here. So I could take away all of the minor grid lines, and then it looks a lot simpler and a lot less messy. So we'll call this example 1, and then we'll name these axes appropriately. So this one corresponds to velocity, and that is in meters per second. And then our other axis is power, which would be in watts. Okay, the other thing that we don't want to just call this series 1. It bugs me when people do that. So I can come in here and I can edit that title to power versus velocity, or whatever I want that to be. Later on you'll have specific data, so it'll be the sand analysis or the clay analysis or any of those kinds of things. So I have those. This graph's looking pretty good. If I wanted to change the shape again, I could click on the markers and then come over here to marker and then change my marker options and use one of these built-in ones. And then if I wanted to change the color to something different, I could change that as well to make it black or whatever it is I want. And then also would have to change the border, right? Because we have to change those to the same. So that's how you would do that one. If we wanted to do a second graph, it looks like the same thing, but it's on a log-log plot. We could insert another scatter plot. We'll just do this one over the top of the old one. And so again, we would do these exact same things. So let's actually just start with this plot. We can just adjust this one. You guys can go back and make another one if you want, or you can add on to this one. So I can click on this axis here and come over here to the, if you notice, it organizes things. We have this drop-down menu of all the things we can do with this chart, and then we have different areas under each of the options. So kind of like a folder structure. I can look at the color of the fill and the line. I can look at some shadow things. Don't do that on your graphs. I can align things differently. Or what I'm really looking for here is how can I make my axes different? So if I want this to be in a logarithmic scale, I would want to get both of my axes. So I've got the horizontal axis. I also need to look at the vertical axis and make it logarithmic. And now I need to adjust my bounds. So our maximum value is 1500. So maybe in this instance, it's actually showing that our bounds are within that. So we need to go adjust our horizontal axis though, because it is pretty far out. So we want its maximum boundary to be at 30, from 1 to 30. So that's something that we can do there. And then let's go back and look at that vertical axis again and make sure. So here we're at 10,000. Our maximum point is 1500. So we can make it 2000 and see how that works for us. So then it's by tens, it's only going to 2000. We can't see that line though. So something that we want to make sure that we do is turn on our major and minor grid lines again. Here they would make a lot of sense to have since we're on a log-log plot. So that is how you would do that. If we come back to our second example, looking at these two different ones, again, we have two data sets here. I can highlight all of that data, click insert, and then add a scatter plot. Easy as pie. I have two different color series. Again, I'm going to come and adjust my layout to something that makes more sense to me and what I prefer, preference-wise. On the y-axis, we have, going from 0 to 120, we have the electrical consumption. And that is in watts. dots. And then on the x-axis, we have luminous flux, which is in lumens, or LM. Okay, so next thing I would want to do is put a chart title on here above the chart and call this CFL versus incandescent. Not sure if that's spelled right. Incandescent, yeah. Electrical consumption, or bulbs. Bulb comparison, right? And then the rest of that will tell us what's going on. Usually in a title, you want to have all caps. The series names are not appropriate here. We want to know which one is the incandescent and which one is the compact fluorescent. So I can come in here and I can edit the titles. This is for series 1, which is the light orange dots, which is the incandescent bulbs. So and then we'll also edit this other, which is a CFL bulb. So now it makes more sense. Again, if we were going to print this, we have to think about people who are colorblind and or people who are going to print on a black and white printer. And so we want to go in and we want to change our marker options to at least 2 different shapes. But we may also want to come back and change that color to some sort of this on this grayscale. So maybe we do one in black, and then we do, there's our fill. We do one in black, and then we do the other one. We can leave it that shape, and then we can just make its fill gray of some sort so that we can tell the difference between the two. So that looks much better. So the next thing that we would want to do is go back and try to find these data points in here and calculate them. And so the way we do that again is we can come to our design and we can add trend lines, and these are linear again. We can look at all the different ones. I prefer, you can do it that way. I prefer to add a trend line this way because it gives me my options quicker. And so, or it gives me more of my options that I can easily interact with, because I always like to display the equation and the r squared value of the set equation nearby. And maybe I put this by the line so that they know what that equation is for that one. We would also want to do the same thing here. Add a trend line, it's linear again, and then display our equation. So now that I have those, I can come in, and for data set 1, I can also change the color of these lines. I don't have to put them in, I would want to leave them in there, but I can change the way a trend line looks based upon, I can make it a solid line, I can make it a gradient line, I can make it automatic. I can also change the dash type to be solid, or all kinds of different types here. So I could distinguish between those two that way, so that people would see that, and then I can make them the same color as their dots so that we can see what they correspond to. So that may help us. So that helps us see the linear trend line. I could go back and edit and say linear trend line in that if I wanted. But let's calculate these values and then we'll be done. So on this one, we're looking at the top equation here. So it's 0.0679. 0.0679 times x. X in this instance is the lumens, plus 12.559. So that's somewhere between 16 and 38, 200 to 400. This should be the correct value. Then I can take that cell and copy it down to our 1250. I know that it should be less than 105, but greater than 68, so I feel like those are pretty good. And then again, this one should be less than 4, so this is 0.122 times the lumens, plus 2.6304. So something's up with our equation there. I forgot a 0 beforehand. And it's actually changing our R squared value. So that's also something that's interesting is, as you notice, our R squared value, those points are going on there now. So that's something to notice. You wouldn't want to do that if you had to turn this in, you would want to graph it and then create a separate table that does this, because it's going to change our R squared value to be really much closer to 1 than it was before. So that is how you do that. That's all I have for today. In class on Wednesday, we'll do some more graphing and look at how to put in some lines to maybe determine what our min and max are, and put in some special features that help us see some different things in data. See you guys then.